All right, let's get going. Good day, everyone, and very welcome to today's webinar, HD SuperNEST. My name is Justin Tennyson. I'm the SigmaNEST product manager. The main focus of today's webinar is just to show you all how you could save a tremendous amount by utilizing SigmaNEST nesting algorithms to its fullest. Just before we get going, some administrative notes. Just take note that your mic and video has been disabled for the duration of this webinar. There's a chat section on the right-hand side. So if you do have any questions, please feel free to post your questions there anytime during this webinar. My team is also joined, so they will respond to those questions. And lastly, this webinar will become a bit more technical later on, but it's not intended to be a training session, but rather as a briefing. I'm sure everyone in this session would like me to skip over to point 1 and 2 and get straight into the results and savings. However, I would just like to share all the solutions we have to offer, and then we'll be taking a deeper look into the different nesting engines and SigmaNEST packages. And lastly, we'll have a Q&A session to answer any unanswered questions in the chat or new questions that you guys might have. So with that being said, let's have a closer look at our solutions. Majority of sheet metal fabricators and engineering shops are quite familiar with the best nesting solution, SigmaNEST, but not all of you guys are familiar with the other solutions we have. As seen, our product range consists of an additional 18 software solutions, from quoting, CNC press brake, and tube cutting solutions, through to shop floor control and our own fully integrated MRP system. Majority of our shop floor tools, like Shop Manager, are all web-based applications. This is just a general overview of the smart software solutions we have to offer that helps our customers expand their potential. So if you guys are interested in any of these software solutions, please feel free to reach out to us after this session and we can discuss it further. SigmaNEST comes packed with a range of features that delivers 5 key benefits. We call it, or as we call it, the 5 M's. That is for material, higher nest yields and less material waste. For management, that is full integration from all areas of your operation for tracking, traceability, and to avoid the unnecessary data recapture. For motion, our solution provides a boost in efficiency due to faster programming times, faster cutting paths, and also shop floor solutions. And then for manpower, SigmaNEST data is all in one location. SigmaNEST empowers your team with fast software to increase your shop floor capacity and automation. And lastly, SigmaNEST allows you to run all of your machines from one software platform. This allows you to share skills across the factory, therefore increasing efficiency. But for today, we'll be focusing on the first M, which is material. Our nesting engines can be split into 3 categories. That is standard algorithms, HD algorithms, and lastly, in a category of its own, HD SuperNEST. For standard algorithms, user 2 is definitely our favorite nesting and a very popular nesting engine strategy to use amongst all of you guys and our customers that results in higher nest yields. Our standard algorithms has been around for quite some time. These nesting engines does not require a lot of PC resources to run. They also produce an efficient nest in its relative short time. On the other hand, the HD algorithms leverage a bit more computing power to get an effective nest. HD engines in particular, HD Advanced True Shape, takes a bit longer to nest than the standard algorithms, but produces lower scrap rates. Initially, we thought that there cannot be a better nesting algorithm than user 2. And then came along HD Advanced True Shape and HD SuperNEST. Just a bit more on HD SuperNEST. It is a time-based nesting algorithm that continuously nests and re-nests parts until the material yield cannot be improved within the set time interval. When a better nesting is found, it is accepted and the timer resets. Nesting will continue and continue until no better nesting can be found in the set time interval. So far, we've reached a minimum average of 4% savings on the best nets given to us by customers like yourself, which was done both manually and automatically. We'll get into those details shortly. This nesting matrix will just give you more info on which SigmaNEST base package comes with which nesting algorithm as a standard. HD SuperNEST, as you guys can see, is an add-on module that can be added onto your current SigmaNEST base package. Let's move on and take a deeper look into the results on some of these nesting engines. The test we performed to illustrate the effectiveness of each of these nesting algorithms was done on a common material grade and thickness. We've chose 12mm mild steel and the plate size was 3x15. I'm sure a majority of you guys in this session is quite familiar with the parts presented in the right top corner. This is the most common tutorial parts that we use when demonstrating SigmaNEST. So let's use these parts as our base to show the material savings on each nesting engine or nesting result per SigmaNEST package. Just to recap, we've used mild steel 12mm, 3x15. In this test, we've kept all the part quantities the same. All the part leadings, part clearance and edge distance were all kept the same. The only thing we did change was the nesting algorithm and then performed an auto nest. The nesting result we got from the standard true shape nesting algorithm found in all SigmaNEST packages except auto nest. Generally, when a nesting looks good, it is a good nest, right? So let's see how the different algorithms we have will save on material. As a side note, the SigmaNEST user base is split in half. We found that 50% of SigmaNEST users trust and only does AutoNest by means of any of these nesting algorithms, whereas the other half relies on user experience and knowledge to manual nest all jobs for cutting, which can be time consuming. Please comment in the section on the right hand side which strategy you guys like to follow. Do you like to use manual nest, AutoNest, or rather a combination of the two? The results for the summary nesting, it took 4 seconds. As you guys can see, it took 4 seconds to perform this auto nest, and a scrap percentage of 37.1 was achieved. Not bad at all for a 4-second nest, I might say. The next nesting was performed on the HD Advanced True Shape Nesting algorithm. This algorithm is more advanced nesting engine, nests parts more specifically to the part's geometry. The nesting engine is found in SigmaNEST Techno and PowerPack package, as shown in the nesting matrix earlier. The scrap percentage for HD Advanced True Shape is now 30.6. That is a massive saving of 6.5% from the previous True Shape nesting algorithm. If you do have SigmaNEST Techno and PowerPack, I would highly recommend that this nesting engine needs to be used for greater material yields. Please take note of the nesting duration. The nesting only took about 52 seconds to perform with that savings of 6.5%. I have to admit, I was quite shocked to see the improvement from True Shape to HD Advanced True Shape. And I really didn't think a better nesting is possible. Well, HD SuperNEST proved me wrong. HD SuperNEST saves an additional 2.2% on material from the previous nest on compared to the standard True Shape algorithm. Total material savings went to 8.7. The nesting result also took about an hour longer to nest than the initial True Shape nesting that we did as a base. That's quite impressive. Let's take this even further. I didn't think it was possible, but we took this nesting engine that you guys see here from HD SuperNEST and we applied an advanced nesting feature called common line cutting. I'm sure you all are quite familiar with that feature. The material savings went up again with a total of 11% when compared to the standard TrueShape algorithm. Compared to the HD Advanced TrueShape nesting engine, it's an additional 4.5% savings and an additional 2.3 material savings over the already impressive HD SuperNEST as shown in the previous slide. Before moving on to the material savings, I'll give you guys a second or two. Please go ahead and just type in the chat section on your right-hand side your average tonnage. Just give a second for that. We called a few suppliers and worked out an average price for a 3x15 12mm mild steel plate. We have used this average price to illustrate the previous material savings in rand values based on the various nesting engines we just discussed. There is obviously quite a few solutions to look at. Each client will have a specific solution which fits their application and needs best. Now let's be honest, percentages sounds impressive, right? But let's do the actual cost calculation to see if it's worth the investment to upgrade your SigmaNEST to a higher base package or to acquire the HD nesting module to your existing product suite. From what we've seen in the industry, let's split this calculation into 3 categories based on average tonnage cut per month, right? For small customers, we will use an average of 100 tons a month. For medium, we'll use 500 tons, and for large customers, we'll use 1,000 tons plus. For small customers, cutting an average of 100 tons a month by upgrading your SigmaNEST package to SigmaNEST Techno or PowerPack, where you have the HD Advanced Nesting Engine included, let's do the calculation. Savings is 1558 times 100. Fairly basic math. That's an impressive 155,000 Rand savings per month. Maybe that sounds impossible. Times a year, it's quite impressive. Let's do the same calculation for a large customer cutting 1,000 tons a month. Large customer will generally be on a SigmaNEST Techno or a SigmaNEST PowerPack, which means they are already utilizing HD Advanced TrueShape. So let's look at the difference in savings per ton based on the SuperNEST feature. So if a large customer were to add HD SuperNEST, they would save on average 527 Rand per ton. Cut the whopping 1,000 tons a month. That's impressive savings per month. Times a year, maybe it's impossible. All of you know the tonnage you cut each month. With this number in mind, you can get a potential of the figure which you could save per month. So please feel free to do a quick calculation on your side. We can have a quick Q&A session in the chat. If there's any questions we do not get to, you're more than welcome to send it through via email. Please go ahead and submit your questions now.